Hi there chemistry students, organic analytical techniques exam question, usual format applies. So this question is predominantly about organic analysis for year 1. There is some NMR for year 2, but don't worry too much about that. We've got oxidation of alcohols and infrared spectroscopy. The other analytical techniques that you need to be aware of are the wet chemistry techniques involved with testing for the carboxylic acid group with sodium carbonate, that should fizz. The test for saturation, the carbon-carbon double bond, the orange bromine water will be decolorized in the presence of a carbon-carbon double bond, and distinguishing between aldehydes and ketones. For example, you might want to use Tollen's reagent, ammoniacal silver nitrate, which will give a silver mirror with the presence of aldehydes and not with ketones. You could also use Benedict's or Failing solution. You also need to be aware of mass spectroscopy for the year 1 specification. Just pause the video when you see the black text. The model answer will follow in blue text, and red will be any additional information. So here's the first part of the question. Have a read, have a go, press play when you're ready to see the answer. So welcome back. What we have to be aware of is that 2-methyl-butan-1-ol and 2-methyl-butan-2-ol, well, they're different types of alcohols. They've got different classifications. Different alcohols can be classified as primary, secondary or tertiary, and as such they react in a different way. We can use acidified potassium dichromate. Essential that you include acidified. It won't work unless it's acidified. This is an orange substance and it's an oxidizing agent. You can alternatively put H+/K2Cr2O7, or you could use sodium dichromate, or you could say that it's sulfuric acid, which we use as the acid, but it's acidified potassium dichromate. With 2-methyl-butan-1-ol, this will be oxidized, and so you will see a colour change from orange to green. However, 2-methyl-butan-2-ol is a tertiary alcohol, and as such it will not be oxidized, so no change will be observed. Okay, so here's the next part of the question. It's about NMR. Year 1 students don't need to worry about this, and Year 2, I don't believe it's on the advanced information as a critical part of the specification. But if you'd like to have a go, you can do. I will give a very brief explanation. Okay, so welcome back. Singlets and triplets. So a singlet means a proton which has got 0 adjacent protons. A triplet means a proton which has got 2 adjacent protons. It's just a case of trying, so I would suggest that you start drawing isomers of C4H8 and try to make it fit the information. But there are the answers. So from the left hand side there are molecule A. We've got 1, 2, 3 different proton environments. Going from left to right, we've got a CH3 singlet. The next carbon has got no protons on it. The next carbon after that is a CH2, and that will be a quartet, and the final carbon will be a CH3 triplet. The triplet quartet is indicative of that CH2 CH3, whereas B, that CH3 there, I believe will be a singlet on the left hand side at the top, and it's identical in terms of the environment to the carbon attached to 3 hydrogens on the right, and the CH2 below it, it is also a singlet. So yeah, tricky question, but a full explanation when we do NMR for Year 2 students. So now we turn our attention to carbon-13 NMR. Pause the video, have a go, and press play when you're ready. Okay, welcome back. So the things to spot with this question, C6H3Br3 should immediately make you start thinking of aromatics. As soon as we got to the fact that we've got aromatic compounds, there's C, which has only got has only got 2 environments, and D has got 1, 2, 3, 4 environments. So you could label those up, but as I say, we'll look at more detail at NMR for Year 2 students in other videos. Okay, so we've got an infrared question next. Pause the video, have a go, and press play when you're ready. Welcome back. First thing to note is that infrared tells you about the bonds that are present. Don't jump straight towards saying what kind of functional groups are present. The next thing is that we need to be aware of or familiar with the particular shapes. You don't want to rely on the data sheets in the exam to tell you where to find these characteristic bonds, these characteristic absorbances. You need to be able to know what you're looking for before you find it. For example, in this trace here, we've got a little peak at about 3000 per centimetre. That's got nothing to do with an alcohol OH or a carboxylic acid OH. That's because of a CH bond. So, yeah, know the particular characteristic shapes. In molecules E, F and G, the noteworthy bonds are the carbon double bond oxygen, the carboxylic acid OH, the alcohol OH, and that's it. What have we got on this particular first trace here? There's no alcohol OH, there's no carboxylic acid OH, but there is a C double bond O. So there's our C double bond O. It's sharp. Sometimes it has a shoulder on it, but in this case not so much. It's sharp and it's about 1700 per centimetre. In this case I think it's about 1750 per centimetre. There's no alcohol OH, there's no carboxylic acid OH, so that must be G. Okay, take a look at this trace and see if you can identify which molecule this trace is related to. Welcome back. This is definitely an alcohol, and I would refer to the absorbance at about 3300, 3400. I would refer to that as being smooth. The little peak next to it is the CH bond. And we've also got a C double bond O at 1700 per centimetre, and it's got that little shoulder on it there. So that's our C double bond O, and that's our alcohol OH. You must stipulate that it's an alcohol OH, and so what's got an alcohol and the C double bond O? It must be compound F. Okay, taking a look at the next one, I think we've identified which molecule it should be, but see if you can't identify the particular bonds and the absorbances on the trace there. Okay, welcome back. We've got our C double bond O again, and this time we've got a broad absorbance, so it's not quite as smooth to my eyes, and it's a lot broader. Which is indicative of the carboxylic acid OH, and so therefore this one must be molecule E. Okay.